Hi and welcome. I hope everyone is okay. Now, in this lesson, we will go on our topic. It's called, sampling. And we will learn the different parts of sampling. It's called the distribution of sample means. Okay. Now, in this lesson, we can start this topic. The distribution of sample means different samples or data chosen from the same population will most likely have different, but not necessarily the similar means. The sample mean is the mean of all the items in your chosen sample. Okay, the sample size is the number of items you choose to be in your sample. You can explore the distribution of sample means using any distribution, discrete or continuous, normal or otherwise, so long as it has defined mean value. And for example, suppose you spin a fair four-sided spinner numbered 1, 1, 2, 4 a number of times. With a sample size of 5, you could get the following outcomes. Sample size of 5, you could get 1, 1, 4, 2, 4, and you could get 1, 1, 1, 4, 1, and or you could get 1 or 2, 1 4 1 2 2 1, and the mean or the each possible outcome, and 1 plus 1 2 plus 4 6 and 10 and 11 over 5 becomes 2.4, and 1 plus 1 plus 1 plus 1 plus 4 8 over 5, our mean is 1 over 1.6. 4 plus 1 plus 2 plus 2 and plus 1 10 over 5 becomes 2, and respectively our means 2.4, 1.6 or 2. And it would take a very long time to list all possible samples and work out each sample mean. If we wait, we could create a table showing probability distribution of the sample mean and create graph to show the distribution of sample means. To show how this works, we can begin with the simplest sample size 1 and explore the probability distribution of the means of increasing sample sizes using these fair four-sided spinner. Let the random variable x be the score on the spinner when it's spun. When we spin the spinner, it's equally likely to land on each side. With a sample size of 1, the mean of the sample is the same as the score. And to distinguish between the probability distribution of scores and probability distribution of sample means, we use x up to line to represent the random variable of sample means. To follow the explanation, it's easier refer to the distribution of sample size 1, and notation is x up to line 1. It means we have 1 times spin the spinner, 1 times spin the spinner, and the sample size means 1. If you spin the spinner 2 times, your sample size is also 2. If you spin the spinner 3 times, so you sample size is become 3. Okay, and if your sample size 1, and please remember that the part of the spinner 1 1 and 2 4, so the probability of 1 2 over 4 becomes 1 over 2, and you have a 1 2, so the probability of 2 1 over 4, you have a 1 4, and the probability of 4 1 over 4. The following figure shows the graph of the probability distribution of the sample means of size 1 becomes our graph like this. As you remember, the probability of 1 over 2 also 0.5, and the probability of 2 1 over 4 also 0.25, and also the same the probability of 4. And the expectation, please remember that the expectation formula 1 multiply the probability of 1, 2 multiply the probability of 2, 4 multiply the probability or the probability of 4, and becomes the expectation of the sample size 1 is 2, and the variance, and please remember the variance formula 1 square multiply the probability of 1 plus 2 square multiply the probability of 2 plus 4 square the probability of 4, and minus the expectation square, and it means 1.5. Okay, and if your sample size 2, sample of size 2, if x1 is the score from the first spin and x2 the score from the second spin, so you could 2 times spin the spinner, and we can draw a table and show all possible sample means. And if you spin the spinner 2 times, maybe outcomes 1 1 1 1 1 1 1 1. So, and the mean of sample 1 plus 1 over 1 over 2 mean 1 1 plus 1 over 2, the mean of 1 1 1 is 1, the mean of 1 1 is 1, the mean of 1 1 is 1, and the mean of 2 1 2 plus 1 over 2 1.5, the mean of 4 1 4 plus 1 over 2 2 plus 2 multiply 2.5, like this. If you 2 times spin the spinner, means your sample of size 2, and the sample means here in this table. Okay, from these we can find the probability distribution of the sample means of size 2, like notation, our notation is here. For example, there are 16 possible sample means like this. You have 4 outcome for x2, you have 4 also outcome x1, and your all outcome is 16. And the probability of 1, you have 4 over 16. The probability of 1.5 or 1 over 2, you have 1 2 3 4 1 over 2, so the probability of 1 over 2 4 over 16, and 4 over 16 becomes 1 over 4, like this. The other the other sample mean. Sample means the probability of sample means like here in this possibility table. This probability distribution is the distribution of the sample means of size 2. The following diagram shows the graph of the probability distribution of the sample means of size 2 and 1. The probability of 1 0.25 and the probability of 1.5 0.25 like this. And if we figure out the expectation, the sample size of the sample of size 2, the sample means of size 2 means 1 multiply the probability of 1 to 1 over 2 multiply its possibility, its probability, and our expectation becomes 2, and our variance becomes 0.75. So please remember and notice that the expectation, the sample mean of size 2, the sample mean of size 2, we could find 2, and the variance, the sample mean size 1, we could find 1.5. And in this question, in this example, the expectation, the sample size, the sample mean of size 2, we figured out 2, and the variance, the sample mean of size 2, we could find 0.75, and our expectation also equals each other. But if your variance, the sample mean of x size size 2, we found 0.75, and we can write 1 over 2 multiply 1.5, and maybe we can write 1 over 2 multiply the variance of x, and 1 over 2 multiply x1, maybe the variance of x. Okay, please notice that our expectation also the same if your sample mean of size 1 or the sample mean of size 2, the same their expectation, but their variance inequals each other. And if you notice that the variance of the the sample mean of size 2 equals to 1 over 2 the variance of the x sample mean of size 1. And if the probability distribution of sample mean scores for 3 x up to line 3 is shown in the following table, and we can say also we spin the spinner 3 times. We have outcomes, and our outcomes means sample mean, and the probability of the all outcomes, like here, this table, and our graph is here, and our expectation, if we figure out the expectation, the sample mean of size 3 also 2, and please notice that the expectation sample mean x sample mean of size 1, also the same the expectation of sample mean of size 2, and the expectation the sample mean of size 3, also the same for expectation we can say. But the variance of the sample the sample mean of size 3 becomes 1 over 2, and please notice that the variance of the sample means of size 1 we could find 1.5. The variance of the sample mean of size 2 we could find 0.75, and the variance of x the sample mean of size 3 we would find 1 over 2, and also I can write 0.5, and their relationship is here 1 over the variance of the sample mean of size 2 means 1 over 2 multiplied the variance of x, and the variance of the sample mean of size 3 means 1 over 3 multiplied the variance of x, and we can say easily the variance of x and the sample mean of size 1 the same. So we can write 1.5 instead of the variance of x, and 1 over 2 multiplied the 1.5 becomes 0.75, and we can write 1.5 instead of the variance of x, and 1 over 3 multiply 1.5 becomes 0.5. Okay, we explored the variance, different size, different the sample mean of different sizes. We explored their relationship, and we can say other way like this: the sample mean of size 3 we can write 1 over 3x1, 1 over 3x2, 1 over 3x3. x1 means the first time spin the spinner. x2 means your outcomes, but the second time spin the spinner. x3 outcomes means the third one spin the spinner, and the sample mean of size 3 means also we can write here. And please remember that the previous topic, linear combination of random variables, and we can write here 1 over 3 multiply the expectation of x1 plus 1 over 3 multiply the expectation of x2 plus 1 over 3 multiply the expectation of x3, and also the first time, the second time, the third time, and also the same the spin, also the same spinner, so their expectation also the same, and we can write here the expectation of x. So all for all size of the mean, the sample mean, their expectation also every time the same. But we couldn't say for variance, and we can write the variance, the mean, the sample mean size of the sample mean of size 3. We can write 1 over 3 x1, 1 over 3 x2, 1 over 3 x3, and also their variance the same, x1, x2, x3. And please, a linear combination of random variables, notice that, remember that 1 over 3 square, the variance of x1, 1 over 3 square, the variance of x2, the 1 over 3 square, the variance of x3, and 1 over 9, the variance of x, we can say, because the same spinner, like here, their variances are the same, plus 1 over 9, the variance of x, plus the 1 over 9, the variance of x. It means 3 over 9, the variance of x, means 1 over 3, the variance of x. And we can also say the mean, the expectation, or the sample mean of size n, also nu, or mean, also or expectation. So for all size, but we couldn't say for variance. We can say for variance, and the variance of the sample mean, the sample mean of size n, we can say 1 over n multiplied the variance of x. Okay. Now in this lesson, in this part, we will solve a question about the sample mean of size. Show that for samples of size 1, or x, you can say, or x1, you can say, drawn from a fair six-sided die numbered 1, 2, 3, 4, 5, and 6, and the expectation of x1 3.5, and the variance x1 35 over 12. We will show this situation. And please remember that you have a die and fair six-sided die 1, 2, 3, 4, 5, 6, and their probability is 1 over 6, 1 over 6, 1 over 6, and then. And if you figure out the expectation of x, you can say also the expectation of x1. You can say also the expectation, the sample mean of size 1. Also the same notation. And if you remember the formula of expectation, 1 multiply 1 over 6 plus 2 multiply 1 over 6 plus 3 multiply 1 over 6, and then 6 multiply 1 over 6. It means 21 over 6, and we can say 3 over 6, and we can say 1 over 2. Okay. And our expectation of the sample mean of size 1, or the expectation of x, we can say 1 over 2. And the variance, please remember that the variance formula, and the variance of x, and also you can say the variance of x1, and also you can say the variance of the sample mean, of size 1, also the same, and it means 1 square multiply the probability of 1 plus 2 square multiply the probability of 2, and then 6 square multiply the probability of 6, and minus the expectation square. So 3 1 over 2 square, and you can say 1 plus 4 plus 9 plus 16 plus 25 plus 36 minus 7 over 2 square. Okay, and now their result means 91 over 6 minus 49 over 4, and then 182 minus 147 over 12, and it means 35 over 12 our variance, and then work out expectation of the sample mean of size 2 and the variance of the sample mean of size 2. And please remember that expectation don't change, and you can say the expectation the sample mean of size 2 also the same the expectation the sample mean size of size 1, and also mean the expectation of x. It means 3 1 over 2. We could find the 3 1 over 2, and the variance doesn't for variance we couldn't say we can't say the accused to like expectation such as expectation, but we can say the variance of the sample mean of size 2 means 1 over 2 multiply the variance of x means 1 over 2 multiply 35 over 12, it means 35 over 24. Okay, for example you can say the variance of the sample mean of size 3, you can say 1 over 3 the variance of x, and 1 over 3 is 35 over 12, and you can say 35 over 36, and go on. Okay, now in this lesson we finished it's finished so have a good lesson and have a good day.